He gets solubility product. We talked about the fact that substances that dissolve in water, they would eventually form an equilibrium when they are saturated, especially ionic compounds. And we talked about ionic compounds dissociating and forming an equilibrium with its crystal. Okay? There's going to be more ions dissociating from the crystal, but at the same time, there's going to be crystallization happening as well. So the solubility product was the product of the ions. It was the concentration of the product divided by the reactant. You don't write the reactant because the reactant was a solid. So we learned how to calculate the KSP value for different substances. Now we're going to do what we are going to do is we're going to do the opposite question, which is in this question, but let me just do one more question quickly about finding KSP. Okay, just one more question so we can just for finding KSP. Just one second, let me find a question. So for example, over here, and he's just asking for the units. Just one second, one proper question. Yep, this one. So let's try and do one more question about KSP. So he's asking for, I mean, this question is asking for writing the expression for KSP of calcium phosphate. Now, when calcium phosphate dissociates, mixes in water, it's going to produce 3 calcium ions, and it will produce 2 phosphate ions. So the KSP expression would be that it would be the product concentration. So it's going to be calcium concentration, and that's going to be cubed. And it's going to be phosphate concentration, and that's going to be squared. And divided by the reactant concentration, which is a solid, so you don't write that in the expression. He's asking about the solubility product of calcium phosphate, and he's told us what the concentration is. It's and remember, he's told us the concentration of calcium phosphate or the solubility. That is the amount that has already mixed. So using that, I'm going to try and calculate the concentration of the ions. So that means 2.5 solubility is the amount that has actually already mixed. So using this is the amount mole per dm cube that has dissolved. So it's going to produce how many calcium ions? It's going to be, the amount of calcium ions will be 3 times more. So that's going to be 7.5 times 10 to the power minus 6 mole per dm cube. And the amount of phosphate ions will be 2 times more. That's going to be 5 times 10 to the power minus 6 mole per dm cube. And you're going to put them in the KSP expression, which would give you, like if I substitute it over here, it's going to give me calcium ions, that's 7.5 times 10 power minus 6, and that's cubed. And the other one is phosphate, that's 5 times 10 power minus 6, and that's getting squared. So क्या value आ रही है for this? Anyone see? Shian, Abia, can you try and do this? So we are getting 1.05 times 10 power minus 26. 10 power minus 26. Okay, that's the value that we're getting. And the unit would be concentration cubed times concentration squared. So it's concentration to the power 5. So mole per dm cube to the power 5, that's mole 5 and dm cube to the power 5 would be 15. So you're going to get this. Anyways, that's your KSP value. That's how you're going to calculate this. Now, one thing about KSP is, now coming back to this, okay, that was question type 1. Remember this, that if KSP is large, that means the substance is more soluble. And if KSP comes out to be really small,
सर
Haji,
सर आप वो क्वेश्चन शो कर सकते हैं?
ये वाला.
ओके सर.
Acha, so one second. Acha, so KSP is small, that means it's going to be less soluble. So KSP gives you an idea about how much ions are going to be produced when an ionic compound dissolves. Okay, so something that is not very soluble, it's going to have a very small value of KSP. Which is this one over here has a really small value of KSP. That means it's not going to be very soluble. Okay, that's one thing. Now the other type of question that you're going to get about this is that the KSP value will be given. So now what we're going to do is the other type of question. And in this type, the KSP value is given. So you're supposed to find solubility. Now, what happens in this question is that, for example, they told us that EgCl look at some other ion. Let's say they talk about KSP of FgCl2, and they give us a value. They tell us that it's 2 times 10 power minus 4 mole cube dm minus 9. Now they're asking us for the KSP for the solubility of MgCl2. Like, what is the concentration of MgCl2 in solution? Now you're going to use this MgCl2. You can write the expression that MgCl2 will dissolve. The solid MgCl2 will dissolve, and it will be in equilibrium with magnesium ions and Cl ions. So you'll have your aqueous ions. The KSP expression for this will be it's going to be Mg ion concentration into Cl ion concentration, and that's going to be squared. Now you want to find the solubility. For solubility, you would assume that you're going to take solubility as X. Yeah, that's the unknown. So you're going to take it as X. So if X mole per dm cube dissolves, how much magnesium ions will be produced? That's going to be X as well. And how many Cl ions will be produced? That's going to be 2X. Okay, the amount of Cl ions in the solution will be twice as many as MgCl2. Okay, it's going to dissociate. There'll be X mole per dm cube of Mg ions, and there's going to be 2X mole per dm cube of Cl ions, 1:2. And you're going to substitute these values in the expression. You already know what KSP is. That's 2 times 10 power minus 4. The magnesium ion concentration is X. The Cl ion concentration is 2X, and that's squared. And you're going to try and solve for X. It's going to become 2 square will be 4, so it's 4X cubed. That's equal to 2 power 10 power minus 4. and take the 4 to the other side and find what the answer is. What do you get for x? क्या बन रहा है इसका आंसर? अच्छा इसका Alicia, that's people are getting two different answers. Needs, I mean, this is 5 times 10 power minus 5. X would be 0.0368, I think. X will be 0.0. Okay, that's going to come out to be 0.0368 mole per dm cube if you cube root it. Okay, so is this clear? Sarah, is this clear? Clear?
Yes, sir.
So just remember that it's just the opposite, that you don't know the solubility, you should take it as X. So the ions in the solution will be, so, and remember solubility is the amount that has already mixed in water, that has dissociated. So x mole per dm cube, this is 2x mole per dm cube. You know the KSP expression, you plug in those concentration in terms of x and you just do the reverse. You already know the value of KSP. So there's just two types of questions. They'll just build a moles question on top of it. So we'll just try and solve some more questions related to KSP. And then just 1 second. That's K. 1 second. So we'll just move on from it. Okay, there's not much in KSP. So here's probably an interesting question. If now that's a big question on KSP. Usually you don't get a big question on KSP. So they're saying that monuments made of marble or limestone, such as Taj. So this one is going to be a slightly more complicated question, but remember, it's just going to be the same thing. It's you just have to do the same thing. So they're saying that they're made of marble or limestone. That's calcium carbonate when they're talking about marble or limestone. Now, such as the Taj Mahal in India and the Mayan temples in Mexico are suffering erosion by acid rain, the carbonate stone is converted by the acid rain into the relatively more soluble sulfate. So they're saying that this is less soluble, this is more soluble. Write an expression for the solubility product of KSP for calcium sulfate. So when calcium sulfate dissolves, the solid calcium sulfate will form ions, dissociate. It will form calcium 2 plus aqueous plus SO4 minus 2 aqueous. So your KSP expression, they're asking for the KSP expression, will be calcium ion concentration times SO4 minus 2 ion concentration, right? So that's a KSP expression. And they've told us that the numerical value of this is 3 times 10 power minus 5. Use your expression to calculate the concentration in a saturated solution. So they're actually asking for the same thing. Do the reverse. So let's assume x mole per dm cube dissolves. So how many calcium ions will be produced? According to the ratio, it's going to be x mole per dm cube of this. And there's going to be x mole per dm cube of sulfate ions as well. So that means my KSP, so I'm going to use this expression. I know the numerical value, that's 3 times 10 power minus 5. Calcium ion concentration is X, and the sulfate ion concentration will also be X. So it's going to be, so what would X be? It's going to be 3 times 10 to the power minus 5. And you're going to underroot it. So what do you get for this? Quickly, what do we get for this? Since we're getting 5.48 times 10 power minus 3. So the answer to this is 5.48 times mole per dm cube. So that is what X is, right? Clear है सारों को? Umar, Adisha, Sana, Anna, Abia, clear?
Yes, sir.
And the other part now is okay, they're saying hence calculate the maximum loss in mass of a small statue. If 100 dm cube of acid rain falls on it, assume that the statue is made up of pure calcium carbonate and the acid rain becomes saturated with calcium sulfate. So they're saying that the acid rain becomes saturated calcium sulfate. So the first thing is that if it becomes saturated, what is the maximum concentration that a saturated calcium sulfate can have? It's going to have 5.48 times 10 power minus 3. So you know the concentration of calcium sulfate. I mean, this calcium sulfate, you know this, that if it becomes completely saturated, it will be 5.48 times 10 power minus 3 mole per dm cube. What is the volume of the acid rain? That's 100 dm cube, right? I mean, that's the volume of the solution. It's 100 dm cube. So you can find the moles of calcium sulfate using this. But wo jitna bhi statue dissolve hua hai na, it's forming calcium sulfate. So if there's 100 dm cube of acid rain falling onto it, then whatever solution is formed, that is going to be 100 dm cube. So when calcium sulfate gets formed, so the maximum concentration of this calcium sulfate is this. The volume will still be 100 dm cube because 100 dm cube acid rain used BT. So you know the volume and you know the concentration. So you can find moles. Moles is concentration times volume. You don't have to divide by 1000. Okay, it's already in dm cube. So this comes out to be 0.548 moles. So you're getting 0.548 moles. So you know that calcium sulfate that can possibly be formed is 548 moles, right? The equation where you figure out the moles of calcium sulfate. And calcium carbonate moles will be exactly the same. It's 1:1. So that's going to be 0.548 moles as well. ठीक है, तो ये 0.548 जो है ना वो, अच्छा ये जो है वो यहाँ से आया, अच्छा 0.548. So how much statue was dissolved? You're just going to find the mass, which is moles multiplied by the MR. So it's going to be 0.548 times MR is 100.1. Calcium is 40.1 and carbon is 12 and oxygen is 13. So what do we get? It's क्या value आ रही है इसकी? Approximately 54.80 होगा, something like that. I mean, that's a loss in mass, so 54.9 to be exact. So what happened was acid rain fell and the statue dissolved and it ended up forming calcium sulfate. They told us that the calcium sulfate solution, I mean the acid rain, it became completely saturated with calcium sulfate. In a saturated solution where we applied KSP, remember KSP is only for saturated solutions. I was able to already figure out that uski jo solubility hogi, that's going to be 5.48 times 10 power minus 3. I knew the volume as well of the whole solution. I was able to find the moles. And using that, I was able to find the moles of calcium carbonate, which is the limestone statue. He already told me that it's made up of pure calcium carbonate. So loss in mass was 54.9 grams. Okay, clear? I mean, is this clear? Rizwan clear? Sidra clear?
Yes, sir.
So say agla part, that's so they'll probably kind of build a moles question on top of it if it's a big question. This one is a 5-mark question. Actually, it just continues. I say yahan pe wo keh rahe it's saying the life of such monuments is now being extended by treating them with a mixture of urea and barium hydroxide solution. Achha, yahan pe what he's trying to do now is वो अब एक तीसरा part है. That's अच्छा. In case P, there's an effect called the common ion effect. ये मेरे ज़हन से निकल गया था. अच्छा, so there's an effect which is known as the common ion effect. As a common ion effect is that the solubility of a solution will decrease if a common ion is already present in the solution, or solubility of an ionic compound so the solubility of an ionic compound will decrease drastically when what happens when a common ion is already present in the solution. So here is what the statement means, that now if you look at AgCl is like it's not very soluble. Okay, so let's try and figure out the solubility of AgCl. I can just Google the Kp value of AgCl. I mean, that's 1.8 times 10 power minus 10. That's a very small value. So it's already not very soluble at 25 centigrade. So let's try and do the first part, which is I've got Ksp of AgCl, and they're telling me that this value is value that's 1.8 times 10 power minus 10. And that's going to be mole squared and dm minus 6. So first thing is I'm going to try and figure out what the solubility is. ठीक है, वो मैं explain common ion अभी करता हूँ, ठीक है? So we're gonna try and figure out what the solubility of AgCl is. It's not very soluble. So that means AgCl solid will dissolve, and when it dissolves, it will eventually form an equilibrium in a saturated solution. It will become Ag plus 1 aqueous, and it will become Cl minus 1 aqueous. So if the solubility of the compound is X mole per dm cube AgCl dissolves, then the concentration of silver ions will be X, and the concentration of chloride ions will also be X. और आपका जो Ksp expression है, that's going to be what? It's going to be silver ion concentration and times Cl minus 1 concentration. So it's going to be 1.8 times 10 to the power minus 10, which is equal to X times X, that's X squared. So what is the value of X? Ye jaldi se koi bataye, what's 1.8 times 10 to the power minus 10? And the whole thing gets underrooted. So what do we get for this? So kya hai X? Achha, we are getting 1.34 times 10 power minus 5. So again, that shows that it's not very soluble. That shows its solubility is 1.34 times 10 power minus 5. ठीक है. So that kind of shows that it's not really dissolving. It's not producing a lot of ions. It's not dissociating. ठीक है. तो यहाँ पे your Ksp value is like really small. It's 1.34 times 10 power minus 5 ions of mole per dm cube. इसके बने, and there is 1.34 times 10 power minus 5 mole per dm cube of this thing.
सर
हाँ
सर मैं वैसे पता कैसे चलेगा कौन सी वैल्यू होगी जिससे केएसपी लो हो सकती है हाई हो सकती है?
नहीं, वो इसमें केएसपी तो उसने दिया हुआ है।
हाँ
नहीं, वो तुम पूछ रहे हो कि किसना पता लगता है कि केएसपी लो होगी या हाई होगी, ये पूछ रहे हो?
हाँ सर।
नहीं, वो तो मैंने एक्सप्लेन किया था ना कि इफ यू हैड दिस इज व्हाट आई एक्सप्लेन, दैट इफ यू हैव अ वेरी स्ट्रांग आयनिक लैटिस तो वो कम मिक्स होगा ना, इट्स नॉट गोइंग टू प्रोड्यूस अ लॉट ऑफ आयंस। कि अगर आयनिक लैटिस इज वेरी स्ट्रांग, राइट, तो the ions will be very strongly attracted to each other, so they I mean it would be very hard for them to actually dissociate. Clear है?
यस सर।
तो solution में ions की concentration क्या होगी? It's going to be less, right? I mean you won't have a
यस
lot of,
यस
अगर तो if it's a very weak lattice then the amount of ions present in the solution would be a lot, the concentration ज़्यादा होगी. तो I did write this that whenever you have a strong ionic lattice so they usually dissociate less. The strength of attraction between ions, वो मैंने बताया था कि depends on the charge density, the charge, and the ionic radius, right? So I did explain that stronger ionic lattices they usually have lower KSP values. ठीक है, वो उधर मैं लिख भी देता हूँ.
यस सर। सर वैसे वो
हाँ.
मतलब आपने एक्सप्लेन कर दिया लेकिन उसके अंदर वो जो न्यूमेरिकल वैल्यू उसके बेसिस पर बता रहा हूँ लाइक वो 1.34 into 10 to the power minus 5 आप लो कंसीडर करते तो उसकी लाइक नॉर्मल वैल्यू क्या होनी चाहिए
नहीं, वो तो
to be
relative.
considered high or low? अच्छा
मतलब it all depends. वो तो it's all relative, right? तो मतलब it's always, remember everything is always compared to what, like, ठीक है, मतलब अब AgCl जो होगा ना वो कैल्शियम फॉस्फेट नहीं था, उसके मुकाबले इट्स वेरी सॉल्युबल, राइट? Because we just did calculate calcium phosphate, ठीक है, उसका KSP that was coming out to be 10 power minus 26, right? तो उसके मुकाबले में it's like very soluble. But if you compare it with, let's say, the KSP of NaCl, तो what is the soluble product of KSP? पता नहीं दिया हुआ है कि नहीं दिया हुआ. पता नहीं, तो देख लेते हैं. अच्छा, सही, KSP values are given. तो जो soluble होगा, एक सेकेंड, ठीक है. अच्छा, ये आ गया ना. तो जो soluble होगा उसकी KSP value would be like really high, ठीक है. जैसा ये soluble है Na2C2O4, उसकी तो plus 10 power plus 3.26, that means it's very soluble. और जो बहुत कम soluble calcium carbonate, it's 10 power minus 8.48, that's very less soluble. Is that clear? इसको छोड़ दो, PKSP is not in your course, just the KSP value. ठीक है, is that clear?
यस सर।
तो खैर, वो coming back to the point के common ion effect, ठीक है, I had to explain to you what common ion effect was. So common ion effect was okay, the solubility of an ionic compound will decrease drastically when a common ion is present. So here's what's going to happen. Now this is the solubility of AgCl in pure water. There's nothing else. मतलब पानी होगा, पानी के अंदर ना सिल्वर आयंस और Cl आयंस होंगे, right? There's at the moment there's nothing apart from AgCl in the water. ठीक है, so AgCl will dissociate and it will produce Ag+1 ions and Cl ions. कोई बहुत ज्यादा प्रोड्यूस नहीं करेंगे, they'll just be like very few Ag+1 and Cl ions floating around, right? The concentration is already kind of very low. So, but that's still pure AgCl. Now imagine trying to dissolve AgCl in a solution that already has something. It has something else. ठीक है, so let's try and dissolve it in NaCl. तो अब मैं क्या करूं कि I've got a beaker, and now what is happening is the beaker already contains some stuff, and let's say it contains NaCl, और वो 0.1 mole per dm cube NaCl पहले से है, ठीक है, it's already there. So I've got 0.1 mole per dm cube of NaCl that's already mixed in water. So I've got my sodium ions and Cl ions and it's got a very high concentration of sodium ions and Cl ions. Okay, so the concentration is kind of really high. Now what I'm trying to do is I'm trying to do a different thing now. Okay, I'm trying to dissolve AgCl in a solution that already has NaCl. तो इसके अंदर मैं AgCl मिक्स कर रहा हूँ. ठीक है, I'm trying to mix AgCl solid into it. Now, where do you think your equilibrium will shift? हमारे इसी equilibrium को copy कर लेते हैं. ठीक है, AgCl trying to dissolve. अच्छा मुझे तो कि अगर Cl ions की concentration is already high in the solution, that's known as the common ion, because the AgCl is also going to produce Cl ions and the NaCl also has Cl ions. ठीक है, so your Cl ions, that's known as your common ion. It's present in both things. तो अगर मैं इसकी concentration बढ़ा देता हूँ, ठीक है, the concentration has increased. And why exactly did it increase? Because you added NaCl to it, right? तो ये clear idea clear है कि Sara, is this clear? Sidra, आप ये clear है कि
Yes, sir.
ठीक है, I mean, so what I've done is it was an equilibrium. What I've done is I've added NaCl to it, and that's your common ion. It's present in both things. So the Cl ion concentration is already very high. So where would the equilibrium shift? This equilibrium will shift backwards. AgCl will not be able to dissolve. According to Le-Chatelier principle, if you increase the concentration of your Cl ions, the equilibrium is going to shift left. So it's going to form more crystals instead of. I mean, the Kp value, remember, remains the same. If जितने भी equilibrium constants हैं, there's only one thing that changes that value, and that is temperature. Apart from temperature, nothing else kind of changes the value of Ksp. ठीक है, any equilibrium constant, जितने भी हम पढ़ेंगे ना, that's only temperature. So Ksp remains the same. So this would make AgCl less soluble. So due to the presence of the common ion, the AgCl equilibrium shifts to the left, or the one that's given above. Okay, so that one shifts. And since it is shifting to the left, right, solubility decreases. और यहाँ मैं वो ऐड कर देता हूँ कि जो KSP है ना, only changes with temperature, otherwise it's not going to change. ठीक है, so it's only going to change with temperature. अच्छा, but anyways, last point. Now there's going to be a numerical question after this. ठीक है, hopefully everyone gets this, that AgCl will not dissolve in NaCl. Yeah, it's going to dissolve, but it's going to be even less soluble. So now the numerical question after this is that they're going to ask you about the new concentration of AgCl that dissolves. ठीक है, तो आपका जो question है, find the new solubility of AgCl. So find the new solubility of AgCl. And the way you're going to do that is if this is how you're going to find the new solubility of AgCl. Okay. So I already know that it's going to be less soluble, right? So here's what I'm going to do. Okay. I'm going to do the whole thing again. ठीक है, इसको उठा के इधर रखा है. अच्छा, the new solubility of AgCl, let's call that X. तो अब क्या होगा? कम dissolve करेगा. It's going to be, there's going to be less ions produced, right? So this will be X mole per dm cube. And this other thing will also be X mole per dm cube. अच्छा, so both of them will be X mole per dm cube. अच्छा, लेकिन Cl ions पहले से यहाँ पे NaCl is already mixed. So the amount of Cl ions, I mean the Cl ions over here, they're already present in the solution. And what is the concentration of Cl ions? That's 0.1 mole per dm cube. तो यहाँ पे क्या होगा? That's going to be X plus 0.1 mole per dm cube, right? And that's, और ये वाला जो होगा, that's your NaCl. You off कर लो camera just a second. So that's going to be 0.1 mole per dm cube. Hold on one second. Coming from NaCl. Okay, so is this part clear that now I'm going to try and find the new AgCl solubility? And what is happening now is the solution already contains NaCl. So AgCl है तो X mole per dm cube थोड़े बहुत it will dissolve slightly. A few moles of Ag plus 1 ions, a few moles of Cl ions will be produced. X mole per dm cube, X mole per dm cube. Plus there's already NaCl in the solution, so there's 0.1 mole per dm cube of Cl ions already present. ऐसी भी है ना कि I'm trying to dissolve AgCl in a solution that already contains 0.1 mole per dm cube NaCl. तो उसमें Cl ions की concentration क्या होगी? It's already 0.1 mole per dm cube, right? And when I mix AgCl into it, so a small amount of AgCl will also mix. So some ions from Cl ions, some small quantity of Cl ions will come from AgCl as well. See, is this part clear? Okay, I'm trying to mix AgCl in a solution that already contains NaCl. So X mole per dm cube dissolved, it ended up forming X mole per dm cube of silver ions and X mole per dm cube of Cl ions, but the solution already has 0.1 mole per dm cube of NaCl. So the quantity of Cl ions is already very high, right? Is this clear? Is this part clear? Sidra, Anna, Alicia, Rizwan, sab clear hai?
सर आप ऐसे एक्सप्लेन कर सकते हैं सर, थोड़ा सा कनेक्शन का इशू था.
वो था ना कि देखो ना कि AgCl हम डिसॉल्व कर रहे हैं एक सॉल्यूशन में जिसमें NaCl है, राइट? और उसकी concentration is already given to you, that's 0.1 mole per dm cube. तो Cl ions कितने हो गए? That's 0.1 mole per dm cube, already part of the solution. So जब when you try to dissolve AgCl, तो X mole per dm cube will dissolve. So it will form X mole per dm cube of silver ions, X mole per dm cube of Cl ions. But since Cl is a common ion, NaCl may be Cl ions. So there's 0.1 mole per dm cube of Cl ions already part of the solution. So amount of Cl ions in solution क्या हो गए? 0.1 mole per dm cube Cl ions पहले से है, plus वो जो थोड़ी सी quantity AgCl से Cl ions produce होंगे. ये नहीं होगा कि AgCl will completely not dissolve. A very tiny amount will still dissolve. तो वो थोड़े बहुत ions उधर से आ जाएंगे. Is that part clear?
Yes sir.
अच्छा, इस पे ना एक चीज को आप assume करोगे कि it's you're going to ignore this. ठीक है, you're going to ignore one thing and that's this one. इसको लेने की कोई जरूरत नहीं है. Why do you not need that? ठीक है, the reason is if you go back to your original question, when there was no NaCl, the concentration of Cl lines that was coming from AgCl dissolving was already very less, 1.34 times 10 power minus 5, right? So the Xk value was like really small. I mean, really small, right? And then we discussed कि भाई जब common ion होगा, the solubility will decrease further. So the amount of Cl lines that will be coming from AgCl will be even lesser than before. Okay, because the equilibrium will shift to the left. It's not going to dissolve in the presence of Cl lines. Okay, so this X has a really tiny value. वो पहले भी कम थी, अब उससे भी कम होगी. So what is the total number of ions in your solution? Like if this is 0.1 mole per dm cube, the other one is X, right? I mean, you got 0.1 mole per dm cube plus X mole per dm cube, right? But I'm saying that you can ignore X because it would approximately be equal to 0.1 mole per dm cube. Why? Because X has a really small value. वो उसकी वैसे भी बहुत small थी, अब तो और भी small होगी क्योंकि because of the presence of common ion, the solubility will decrease further. So I'm just going to, हाँ जी.
सर हम लोग सिर्फ NaCl वाले को कंसीडर करेंगे इसमें से.
हाँ वो इसीलिए ना क्योंकि वो इतनी small value है. मतलब वो जब NaCl नहीं भी था ना, so when we found X, the X came out to be like a really small value. It's 0.0000134, right?
Yes.
तो AgCl तो Cl lines पहले ही बहुत कम प्रोड्यूस कर रहा था, right? तो I'm just saying कि उसमें वो add भी कर दो, लेकिन it won't make a difference. It's like so small a value. Is that clear?
Yes, sir.
तो वो 0.1 में ना वो X add करने का क्या फायदा? कुछ भी नहीं होगा, वो बस 0.1 के करीब ही होगा approximately, right? So this is one thing that you're going to do. कि जो common ion जो होगा ना, you're going to take the concentration of the solution because the salt is not going to dissolve a lot. So salt की तरफ से जो amount of ions होंगे ना, they would be very, very less. So your approximation will be you can just ignore this X, like 0.1 plus X is approximately 0.1. Now I'm going to write the KSP expression for this. The KSP expression for this is, so let's quickly try and solve this. Your new KSP expression will be, I mean, it's the same Cl silver ion concentration multiplied by Cl ion concentration. Or let's go quickly, look, it's going to be X times 0.1. Or your KSP value, that was what? That was 1.8 times 10 power minus 10. और उसको use करते हुए ना, you will be able to figure out your. So if you use that, you'll be able to figure out what X is. X will be 1.8 times 10 power minus 10 divided by 0.1. So क्या value आएगी? What do you get for this? (1.8 times 10 power minus 9). That's -9. So you can notice that the solubility has decreased. Previously, your solubility was a lot higher. It was your previous X was 1.34 times 10 power minus 5. Yeah, that was a much bigger number. पहले वो ज़्यादा dissolve हो रहा था. But in the presence of NaCl, the solubility has decreased a lot further. It's 1.8 times 10 power minus 9. So that kind of indicates that अब वो और भी कम dissolve होगा. Okay, so the solubility has decreased even further. So there's only one thing that you have to do when you have a common ion. First thing, दो तीन चीजें बस हमने उसे पढ़ी, जल्दी से इसको कर लेते हैं. कल we'll just recap this. If you already have Cl ions in the solution, the solubility of AgCl will decrease. The equilibrium will shift backwards, और वो पहले से भी कम dissolve होगा. ठीक है, it's going to be dissolving less compared to when there was no NaCl. How do you find the new solubility? You're going to do the same thing. Okay, x mole per dm cubed is dissolving. It's going to produce x of this and x of this. But since this is a common ion that's already present in the solution, तो आप common ion की concentration में 0.1 mole per dm cube add करोगे because there's a lot of Cl ions that's already part of the solution. So your total amount of Cl ions in solution will become 0.1 plus x. And I told you to just ignore this x because this x will have a very small value. तो आप उसको 0.1 ही consider कर लोगे. ठीक है, you're going to use the expression. अगर वो ऐसे 0.1 plus x कर लेते ना, you would still have gotten almost the same value. You could have solved using that as well. लेकिन it would come out to be approximately the same value. तो common ion को आपने बीच में ना as it is लिया 0.1. You did the whole expression, you found x, and x came out to be a much smaller value, which agrees to a fact that the solubility will be lesser. So ये clear है? कल इसके थोड़े से questions और कर लेंगे, but is this clear? Common ion effect.
Yes, sir.
ये बाकियों clear, Sana, is this clear? Umar, Shahan, Rizwan, Sidra, is this clear?
Yes, sir.
Okay, we'll recap this tomorrow and we'll just do some more questions about the common ion effect. Okay, the only thing is, just remember, don't take the common ion as x. अगर वो पहले से solution में, you take that concentration as the common ion concentration. That's about it. चलिए ठीक है. Okay, everyone. Take care. Allah Hafiz.